Hey class, hopefully the test wasn't too bad. Congrats on finishing the very first test of the year. And yeah, when we get back to class next time, then we'll go over it. But let's go ahead and continue our lesson. It was originally planned that we were going to do 2 lessons in one day, but I figured maybe that's going to be a little too much, and I want to make sure we have plenty of time. So we're going to do this instead. So please follow along with me as best as you can, and then feel free to pause or rewind at any time. But today we're going to be looking into histograms, so more into it. So our learning objective today I am creating a bar graph and histogram of data about candy so that I can look at similarities and differences with these displays. I'll know I'll have it when I can create and analyze histogram. So we're just going really deep into histograms specifically. So let's go ahead and read over the opening paragraph. So are candy bars getting smaller, or do you just think they are? A poll of 500 people in the US found that 48.3% of them believe that their favorite sweet treats were getting smaller. Well, let's go ahead and dive into it. So number 1 says below is a table of 4 popular candy bars and their weight in grams over several decades. What patterns do you see? So taking a look at the diagram, anything that's blank like these, that's probably because it wasn't around yet, so it hasn't been existed, or it has not existed yet. So anything blank, then we can just leave them alone. But we can see that as time goes on, it looks like, well, not so much maybe Snickers, but for the others, some of them have increased and then some others have decreased. So to answer the first question, below is a table of 4 popular candy bars and weight in grams over several decades. What patterns do we see? To me, what I see is most increased to 1990s, and then the candies, here, let's write better, candies decreased. So I think that's the pattern that we are seeing for the most part. So that's what's happening, at least to me. 2, why might candy bars be smaller now than they were decades ago? There could be several reasons, so I came up with a few. So one of them that I came up with is people are more concerned with their health now than before. That was one thing I came up with. The other thing I came up with is cost of sugar and cacao. Cacao may have increased, which that may be true with inflation. And then the last thing I came up with was, may try to get specific number of calories thus smaller size. So these are the 3 reasons I came up with. Feel free to put more, but please copy all of this down. All right, so let's move on to the opening activity. So we're given more candies. So number 3 says the table below lists the number of grams of 12 candy bars. which we can see over here in the purple circle. Use the table to complete the bar graph. Okay, so we're given the bar graph. So we have the Three Musketeers, the Almond Joy, and all the others. So and then we're supposed to complete the rest of this. So let's go ahead and complete all of that. So we have Skittles at 57. So we're at, so it's probably over here somewhere. So here, I'm just gonna highlight it to make it easier. Okay. And then we have Snickers at 57, so same thing. That's probably what's gonna be best. Then Starburst at 59, so as close as I get to that. Very nice. Twix, caramel flavor. I didn't know there was such thing as that. But anyway, so we're at 57. So right here. And then York Peppermint Patty, so 43. That's probably it right there. All right, cool. So we just completed that. All right. So now what we're doing is use the same data to create a histogram. So let me just reorganize this a little bit. So right now I'm going to go from least to greatest. So let me go with, let's see, the fewest I see is 44. So I'm going to put 43 here. There is another 43, so 43. Then let's see if there's 44, so 44. There's no other 44, but we do have a 45, so 45. 46, we don't have 46, but we do have a 47, so 47. Let's see, do we have a 48? No. 49? No. 50, we do have a 50. And that's the only 50, so next is 51, so we have 51. We don't have 52 or 53, 54, but we do have a 55, so 55. No 56, but we do have 257, no, 357, so 57, 57, 57, and then 159. So this just helps me reorganize what I want to do with the histogram. So I think I'm going to go by, let's see, let's go with 45, no, sorry, so we'll start with 43 to 46. And then let's go with 49. So I'm just adding by 3. So then 52, 55, 58, and then we'll finish it off with 61. All right. So now I'm just going to look over here, what I have in my arrow, just to reorganize myself so I can see that I have 1, 2, 3, and 4. So I have 4 candies that fall between 43 and 46. So I'm just going to, let's see, let me just make a blue one to make it a little bit prettier. And then fill it in. All right, so that's done. I don't have 46, so let's see, but we do have one that falls between 47, so just a 1 right here. 47 falls between 46 and 49. Let's see, 49 to 52, so we are looking for 49 to 51, so I have 2, so I'm just going to make 2. Fill it in. Cool. So I don't have anything between 52 and 54. So that's just going to be left as a blank. But I do have between 55 and 58. So I need 55, 56, 57. So I do have 1, 2, 3, 4. So I have 4 of those that fall in that range. And then last one, 59. So that falls between 58 and 61. So this is what the histogram should look like. For number 5, why might someone be interested in how many grams are in a single serving of each candy? You know, answers can vary here, but the idea that I had is someone might be interested in which weighs the most and compare it to cost. That's the idea I came up with, but answers will vary here, so whatever answer you had in mind, I'm sure that is acceptable. All right, and then just a reminder, this is for 43 to 45, and then this is from 46 to 48, 49 to 51, and then 55 to 57, and then 58 to 60, or technically 61 because that's the very end. Alrighty. Cool. So I believe we already described this from lesson 3. Oh yeah, they even mentioned it right here. But it's just a revision of SOX. So shape, outliers, center, and spread. So using SOX to describe the number of grams of candy bar. And we're still talking about this one from the opening activity. So from my view, let's see, we have a gap. So let's write that part down so that I have right there. So first one is, there is a gap from 52 to 54 grams. And that's something that is important to mention, just because we do want to mention any type of gaps that there are, so which says so here, look for gaps. Let's see, the shape of it. Well, to me, what it looks like is, if I were to draw this, I have 2 hills, so 1 and then 2 right here. So we're going to call that bimodal. So I'm going to say bimodal with 2 peaks of 4 candy bars. And then let's use a different color. All right. So I think we're good with shapes, so we're good with shapes. So I'm just going to check mark it. Outliers. Personally, to me, I don't see any outliers, so I'm just going to say no outliers. So we're done with outliers. So center. Is it mean or median? Quite honestly, because we're using bimodal, I do think that bimodal, or anytime we use bimodal, mean would be better. So with 2 peaks, here, let me write that better. With 2 peaks, the mean, so I'm going to underline that, the mean would be better description. And I'll say that the mean is probably about 50. So that's what this wiggly line means, and in case we don't know, it just means approximately. So I'm just estimating that the mean would be about 50. And then last part, they want us to state the range or IQR, estimate if necessary. Let's see, so 61 minus 43 8, 1. Okay. But the problem is we don't have 61. Our next number is, or our highest number is 59. So if you just use a range, then it's probably, what, 59 minus 43. So 1, 6. So 16. So range is 16 grams. However, if you want to use the IQR, that's totally fine too. In a histogram, it might be a little bit difficult unless you have like this order right here, which I'm not gonna really do right now, just for time's sake. But I would be okay if we just say like the range on this one. All right, cool. Let's go ahead and move on to this part. So same thing, we're just analyzing the given histogram and we're learning how to read it. So A, for the histogram below, describe the distribution using SOCS. So let me just go SOCS. Really quick, I would say this is skewed left. That's my personal opinion because we can see that it kind of starts dying over here. Or not really dying, but it like lowers. So if we were to pretend there's a ball and it rolls, it's going to roll to the left direction. Outliers? I don't think so. So no outliers. They all seem to be pretty close together. Center, because we're skewed, we need median. And then because this would be a perfect example of range would be better to use in histograms, because we're not given individual data, so we can't really figure it out how to find the IQR based off this. So we're going to say, let's see, even though we don't know if 100 is the highest and we don't know if 20 is the lowest, but if we really have to find the range, then 100 minus 20 will give us 80. So, whoops, that's a terrible 80. 80. So we'll just say approximately around 80. But we're really not sure just because we can't say that 100 is the highest and 20 is the lowest. We don't know that because it's not individualized points. All right. B is asking, can we determine the original data from the graph? Explain. No, not really. Not really. Because, as I mentioned earlier, because there are no individual data given. So we don't know that. Or we don't know this information. The rest we can kind of fill out just based off of the graph. So how many students earn less than 60% of their final? So here we have 2, 1, 2, 1. So it looks like the total is 6 students. D is asking how many students took this final. Okay, so now we're asking for the total. So here there are 6 people because it says so right here. This is 9. This is 11. And this is 5. So if we add them all together, so 1 plus 2 plus 1 plus 2 plus 6 plus 9 plus 11 plus 5. All that equals, let's see, 3, 6, 12, 21, 30, 35 students, it looks like. Hopefully my math is right, but I'm almost positive. And then approximate the mean of the data. Honestly, to me, just by looking at it, because it is asking us to approximate, I'm just going to say like about 73. But answers will vary, so as long as you're like within that range, like nearby 73, that's totally okay too. But again, they're asking us to approximate because we don't know the data other than what's given to us. We're given range rather than individualized points, so this is going to be really hard to figure out what is the actual mean of this. All right, cool. So let's go ahead and answer 8. So use the histogram at the right to answer the questions. So we're given this diagram right here that I have circled in red. How many cherry trees here between 70 and 74.99 feet in height? How many trees here? Oh, okay. So it's asking this part. So it is between 70 and 75. So that's going to look like 8 right there. 8 cherry trees. How many cherry trees were measured altogether? Well, we have 3, 3, 8. This looks like 10. This looks like 5. This looks like 2. So we have 3 plus 8 plus 10 plus 5 plus 2. So we have 6, 14, plus 10, so 24, 29, so 31 it looks like. All right, then we have to go on over to the next page. Can we tell from the histogram what the minimum and maximum are? If yes, what are they? If not, explain. So kind of the same thing as what I mentioned over here on number 7. We're not given individual point. We don't know if 60 is really the lowest number, or if we have any trees that have a height of 60. We don't know that. And we don't know if we do have cherry trees that have a height of 90. We don't know. So no, because we do not have individual data points. And it kind of makes sense too, because if you think about it, between 85 and 90, there are 2 trees that fall in that range, but we don't know if both the trees have 86 as the height, or they could be 85 and 86. We don't know it. We just know that somewhere between 85 and 90 feet, there are 2 trees that fall in that range. So that's why we can't really find out the minimum or maximum based off of this information. And then D, without calculating, what is the mean for this data? Honestly, to me, I would say it would probably be about, I don't know. If I really just have to take a ballpark guess, then probably 72. But any answer will work here because it's asking you to calculate, or sorry, not calculate. It's asking you to not calculate it just by looking at the description, or I'm sorry, the graph. You just have to take a good guess. All right, last one, I believe, before the lesson summary. So Mrs. Reader gave her students a quiz out of 40 points. Their scores were below, which we can see here. So there's a total of 20 scores. And then what looks like is, this is the minimum. So the low point, low equals 18. And then the max, I don't know why I put low, but let's just replace it to minimum. And then the max, it looks like one person got 40, so 40. All right, and then to me, I would like to reorganize this just to make it pretty. So I did mention that 18 is the lowest, so we're good with 18. Do I have 19? Looks like I don't have 19, nor do I have 20. I don't have 21, 22, 23, or 20. No, I do have 24, so we can do 24. Oops, so 24. And I think that's the only 24, so then 25, 26, 27, 28. So I do have 1, 2, 3. So 28, 28, 28. I might have to write a little bit smaller, but that's all right. So 29, I do have a 29, so 29. And then 30. And I think that's the only 30 I have, so 31, 31. 31, then 32, and that's my only 32, so 32. I don't have a 33, but I do have a 34. So 34 and 35, 35, 35, 35. So 4 35s. Yeah, I'm running out of room. Sorry. Then I have a 37, 38, then a 39, 39, and then 40 to finish it off. Cool. So now that I reorganized it, I think by looking at this, I could just do it by 20. So let me do, let's see, 15 to start off with, and then 20, then 25, 30, 35, 40, and then 45 to finish it off. Okay. And now the best part, which is the drawing part. So how many students do I have that fall between 15 and 20 technically? Or sorry, 19 technically. Really, I just only have one because of 18. So just one student. We'll draw that out. How many students do I have that scored a 20 to 24? Then I have one, so I'm just going to make another one right here. How many students do I have that fall between the range of a score of 25 and 29? So I have 1, 2, 3, 4. So I have 4 students that did that. So just going to draw right here. Nice. All right, how many students do I have that fall in the range of 30 and 34? So 1, 2, 3, 4, 5. So I have 5 students that did that. So I'm just gonna color it. Lots of coloring and filling in. All right, how many students do I have that fall in the range of 35 and 40? I'm sorry, not 40. 35 and 39. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 students that do that. So I ran out of room. So I'm going to put 7 right here. So just going to highlight it. Oh, that's a terrible line. And then an 8 up here. So I'm just going to draw another line. So I have 8 students that were able to do that. So just going to draw and then fill it in. Nice. And then lastly, how many students that fall in the range of 40 to 45? Well, I just only have one. One student that were able to do that. Alrighty, cool. So this is relatively what the histogram should look like. And then they want me to describe, here I'm going to use a different color. They want me to then describe using the data of socks. So we'll do that really, really quick. So S, whoops, let's do it different. So S, what is the shape? It's not really skewed. It is more unimodal, so I'm just gonna say it's somewhat symmetrical. Yeah, I would call it somewhat symmetrical. It could be possibly skewed more to the left. Honestly, it's just based on how you explain yourself, but to me, I kind of see it more as symmetrical just because the skewing is not super, super obvious to me. Outliers, I personally don't see any, so no outliers. You know, maybe 18 is the outlier, just because it's like just further away from everyone else, but to me there are no outliers. Center, because I'm saying it's somewhat symmetrical, I'm going to say the mean, but if you're saying it is skewed, then it would be median, but I'll stick with what I have. And then the spread, so because even though we do have the individualized points, I'm not going to do the IQR, so I'm just going to state the range. So range, we have the highest is 40, lowest is 18. So that means, let's see, so that would be 2, and then 3 minus 1 is 2, so 22 would be the answer. for the range. But yeah, but again, when we do take this test, or when we do take our next test, same thing. When we describe using SOCs, it's just how well you explain yourself. You're not going to get dinked or marked wrong just because you have a different opinion than I do. It's just based how you see the graph and how well you explain yourself. So can we please go to the lesson summary? So basically here it's just a brief what we talked about today. I'm just going to label this just because it kind of bothers me. So 1, 2, 3, 4, 5, 6, 7, 8. So just to make it a little pretty. And then for 11, what are the differences and similarities in the bar graph and histogram you made in exercise 4? List your ideas in the Venn diagram. All right, so let's go back to 4. Where is 4? Oh, here it is. So it's talking about this diagram that we made together. So let's talk about the similarities. So they both use the bar because we can see it from here. I'm going to make it in a pink. We can see it from here and from here. They use the bar. So let's go back to this page and say they both use bars. And then let's talk about the uniques of bar graph. So let's go back over here. So this was talked about maybe when we were in lesson 2, when we had to talk about the difference between bar graph and histograms very, very briefly. But what's unique about the bar graph is you can see individual data point, that's kind of given to us here. That's the only way we can make a bar graph is if we're given some type of data. So in this case, we do need the individual point. So we'll keep that in mind. So using individual point. We talked about this before, but bar graphs are used for categorical type of information, meaning we're comparing one thing to another. So we're comparing candies to other candies. That's another reason why we use bar graphs. And then, so therefore it can be categoricalized. And then lastly, most important of the characteristic of the bar graph is there is a space between the bars. So let's write all of those informations down. So the first thing that I said was you can see individual data points. The second thing I said is you can compare one thing directly to another. I'm running out of space. Therefore, your data can be categorized. I think I spelled that right. I hope so. And then lastly, the very important characteristics between a bar graph and a histogram is that there is space between the bars. There is space between bars. So pause that if you need to catch up, but I'm gonna start doing the unique to histograms. So unlike the bar graph, we already know that there are no spaces between, between bars. There may be gaps like what we can see here. There's a gap right here, but that's because there are no frequencies in that range. So that's why there's a gap or a space, but pretty much histograms don't really have spaces between the bars, unlike the bar graph. And then let's take a look at, well, honestly, we could take a look at any histogram, but it wanted us specifically at number 4. So what else we can tell is we can compare one group to another. So meaning one group of candy is over here, and then the other group of candy is over here in terms of like grams. So we can write the data is group I cannot write. I'm at the edge of my iPad. The data is grouped to another. Oh, sorry. Let's do this. Is here. Let's actually rewrite this. So sorry, everyone. I am the worst. But let's rewrite it to make it a little bit manageable. So you can compare one group to another. Yeah, that's worded a lot better. And then one more thing. We can also see here that they're being grouped as intervals. So that I have in red circles. Well, and I can continue it, but we kind of got the point. But last thing, the data is grouped in intervals. And then, yeah, that is it. All right, and then once you're done copying all of this, then let's go ahead and we'll get started with the homework. Thank you, everyone.